Okay, students, so welcome to today's class. Now we're going to start a class. Today we'll be having a center of mass numerical session. Okay, so we are live also. You can see on your screens, everything is live there. Everything is cool. Okay, so we are going to start it now. Let us wait for some students to join because I think that like no one has yet joined. So you must join the class. No, I've started it. Okay. So soon I'll be showing you the slides. Cool. Yes. Okay. So here we are. I am audible. No one has yet joined. No one has yet joined. Let me see on the YouTube what is happening there. Okay. How many students are there on the YouTube session? Yes, available there. Welcome everyone, students. Again, starting it, okay? So we'll be studying center of mass numerical based session. Yes. So first of all, these are the contents of today's class. These are what? Contents of today's class. So we'll be going through the numericals. Then we'll be studying the basic. See, numericals will start. This is since it's a numerical session. We'll be solving all the numericals. Okay, starting from this level, that is a basic level. Then we'll be seeing an average level numerical. Then we'll be seeing the tough level numerical. Okay, and also from different topics, subtopics of this chapter, that is center of mass. See, center of mass is just recently completed. So sir will teach you the next chapter. That is, yeah. So Bhupender have joined. Bhupender, welcome to today's class. How are you, Bhupender? We will, so our today's session is, since you have joined now, let me show you here the slide first. So our today's session is numerical based on center of mass. Is it fine? Good morning, Bhupender. How are you? So we'll be starting now. Okay. So this thing is here. Okay. First we'll start with the numericals. You can put a text in the chat box. Okay. We'll start from the basic, as I've told you, and average, then tough level numericals. Okay. See, here one thing is missing, that is, okay, since you have joined now, I'm launching a poll for you. It's not available. Let me launch a different poll. So how many polls are there basically? Okay, so there is only one poll here. Fine. Is it okay? Bhupinder, can you text me? Voice is audible? Chat box में text करो please. Is the voice audible? Please text in the chat box, or you can unmute yourself and tell yes, audible is sir. Okay. Very good, very good. Okay. Excellent. Okay. So let us start it. See, now just focus on the slides. So first, let us go through the true and false type questions. Okay. First, let us go through the true and false type questions here. Okay. Now it's fine. It's clear. Ready for the true and false? Bhupinder? Okay. See, the first question in front of you is this. The center of mass, it says the center of mass of a rigid body always lie inside the body. Is this statement true or false? So what do you say? Bhupinder? Bhupinder, what do you say? Is it true or false? Any other student have joined? No one. Okay. Okay, so your answer is false. Yeah, it is false. It's already written there. Okay. Is it right? False. Okay, false. What's the reason? Can you give an example? that center of mass of a rigid body always lie inside the body. This statement is false. That's fine. I've given you the solution already. But I mean answer. But can you give an example matching this question? Okay, let me tell you. So suppose you're having a boomerang. Boomerang looks how? It's somewhat like this. This is what? A boomerang. Boomerang, no, we used to play with it. Okay, I mean, we throw it like this. It takes a very big turn like this and it comes back to us and then we catch it. We play this. No, individual person can play with the boomerang. You can play with a duel, like two persons, or you can play with boomerang yourself. Hai Mowgli, you have seen the Mowgli, you know, the cartoons used to come in the television. Now it's available on the YouTube. So Mowgli used to throw as a weapon. Hai This boomerang used to throw as a weapon. Okay. So two more students have joined. Hey, JNV Hingoli students, welcome to today's class. And JNV Sangli students, welcome to today's class. See, students, as I've already started the session, today's session will be, you know, numerical. Okay. I've shown the contents list already. We'll start from the basic, medium level, some tough level, some just one question tough level kind of. And these all levels of questions which we are going to cover today will be basically what kind of? Kaise honge? Will be kind of, I mean, it will cover all the remaining subtopics of approximately all more than 80% subtopics of center of mass. Okay, numerical session. So JNV Hingoli and Sangli students, this question is in front of you. Center of mass of rigid body always lie inside the body. Is this statement true or false? The answer is false. The reason is this. You know, we have seen the cartoon, the animation of Mowgli. Okay, he throws something like a boomerang, and you can also see this. A lot of practical boomerangs are there in the YouTube. Okay, so when I'm throwing a boomerang like this, what happens? The boomerang takes a circle like this, and it comes back, and we catch it. If you try to locate the center of mass of the boomerang, I tell you, see, most of the boomerangs are, see, this I've drawn is like not so curved, but most of the boomerangs are very, very curved. Okay, if I show you the real structure, Mowgli's boomerang was somewhat like this. Okay, so its center of mass, you will not locate here. You may feel it's here, but it's not here. Center of mass of the boomerang lies somewhat here, very near, somewhat here. See here. Okay, and we say it is out of the particles, out of the material of this boomerang. Okay, you can see. See, basically, if I take a rod of some length, symmetric rod, I mean, which is having this uniform mass distribution. If I'm taking that rod, which is having the length equals to L, if you locate the center of mass of this rod, it will be in the center here. Okay. Okay, and it's symmetric. It lies along the line of symmetry. There is no doubt. Okay, but if we focus here for the boomerang, it lies on the line of symmetry. That is cool, but it is outside of the material or outside of this body. It's not inside. In this rod, it is inside, but here it's. I must write this. It is inside here, but here it is outside. Fine. So if we match this explanation example with this numerical, this statement, we can directly say, yes, the center of mass of the rigid body always lies inside the body. No, it can lie. So conclusion is this: the center of mass can lie outside also, inside also. So there is no restriction, fixed condition that it always lies inside the body. Okay? Fine. See? And the conclusion is this. So from here, we can conclude 2 points. First, very good point is this, that center of mass always lies at the center, or at the center. What kind of center? This will not say at the center, but I must write like this. Center of mass always lies at the line of symmetry, at the line of symmetry. This is line of symmetry. Okay, and one point is this: center of mass can be outside, inside. Both the conditions we have to check. So it's not restricted outside. So there is doubt. You can see, and now you can see it is outside. Okay. I hope this example is clear. Answer is false. What is the answer? Answer is false. Okay. Is it fine? Yes. Okay, one more student has joined. JNV Varda students have joined. Welcome to today's class, JNV Varda students. Cool. Okay, Bhupender, yes. So all of you students, if you are comfortable in texting in the chat box, it's just for today. Today is just numerical session. From the next class, again, sir will start, we say, what kind of chapter? Rotation mechanics. Okay, so today be focused on the numericals. Janvi Varda, Janvi Sangling, Hingoli, Bhupender, you are already texting. Very good. So you must also text here in the chat box. Okay, if you're comfortable, I mean that if you're having any doubt, you can text. Otherwise, don't like feel anxiety kind of in texting in the chat box. Okay. See here, I've already given the solution in front of you. The center of mass always lie on the axis of symmetry. If it exists, is this statement true or false? I have given true. I mean, it can be false also. What do you say? What do you say, students? The center of mass always lies on the axis of symmetry. Is this true or false? I have given true. It can be false. It is just for confusing you. So what do you say? What is the answer? Students, what is the answer? Bhupender says, sir, you are right. I mean, my answer is true. He says true is the answer. Okay. So what about other students? What about JNV? Arush have also joined. Arush, welcome to today's class. What do you say? Center of mass lies on the axis of symmetry. Is it true? I mean, I've pasted true. It can be false. Don't go with my answer here. Okay. See, we have already concluded this thing in the previous slide. If you focus carefully, this was the first point which we have concluded. That is, if I highlight this point, center of mass lies at the line of symmetry. You can see here, I have colored yellow. I filled this completely. It's like picture book. Center of mass lies at the line of symmetry. Okay, so that's fine. We are right here. Our answer is true. So you can check this thing from the previous conclusion of the first question. On the PDF, it will be available. Previous conclusion. Okay. Next question. So students, this is the next question in front of you. Now it's a subjective question, by the way. Okay. Numerical number 1. It's a subjective question. You have to solve and text me the answer in the chat box. Okay. So let me write it for you. It's now a subjective question. Okay. So it's a what? Subjective question. So please text in the chat box your answer. Question is this: a Cartesian coordinate two-dimensional coordinate system is given. 3D is not given. Z-axis you are not taking here. We are not worried about the Z plane that is outside. So mass is placed in the plane contained by this plus X and plus Y axis. This is plus X and this is plus Y axis. So in this plane, which is plus YX plane, okay, in this a mass is present which is of 2 kg. Okay, and a mass is there on the origin which is of 4 kg. Okay. Angle made by the line joining these two masses is 37 degree with the positive x-axis. Okay. Now they're asking from you if the distance between the line joining these two point masses is 5 meter distance. Okay. So you have to find the position of center of mass. Find the position of center of mass. By saying like this, keep asking like this, keep find out the position of the center of mass. They mean find the axiom and YCM coordinates of center of mass. So this is your proper question. Text me the coordinates, students. One more student have joined, JNV Kolhapur and Deepika have joined. Welcome to today's class, JNV Kolhapur and Deepika students. Oh, sorry, Deepika, okay, all of you. So, okay, JNV Hingoli students have texted the answer 4/3/1. Okay, all of you must text, okay. So let me write it. Let us see who will win. JNV Hingoli students have texted 4/3/1 as the answer. What about other students? Let me make the list and let us see who will win. This is just a serial number. I'm giving you 2 to 3 minutes for this. Giving you 2 to 3 minutes, 2 minutes at least. Your time has already started. 30 seconds over. Answer in the chat box. Is 4 by 3 one answer right? I mean, anyone of you is getting this answer? No one? Okay, don't worry. I'm solving it now. Okay, I'm going to solve this. See here, what's the question is? Two masses, 4 kg, 2 kg. Okay? See here carefully. So I'm drawing here Cartesian coordinates. You can see this is our Cartesian coordinates. X-axis, Y-axis. This is origin. This is what? This is student's origin. Okay. And one mass is placed here at the 4 kg. This is 4 kg mass. This is 2 kg mass. This is 2 kg mass. 5 meter is the distance between 2 kg and 4 kg mass. Okay? 5 meter is the distance between 2 kg and 4 kg mass. So we need the center of mass coordinates. So how to find? How to find, students? Simple. Dekho, first we'll use the formula for finding XCM, that is x coordinate of center of mass. First we'll use what? Formula for finding x coordinate of center of mass. It is given by like this for the discrete particle system. See, this question is based on discrete particle system. This is based on what? Discrete particle system. Okay. We know for discrete particle system, how we find the center of mass. It's like this. M1, X1, M2. See, these questions are, it will revise all your theoretical aspects also. Okay. M2, X2, Mn, Xn. And if there are, say, Mn particles, whatever. But here we have to extend this formula up to 2 digit only, 2 subscript. Okay. At the denominator, it is M1 plus M2. So from this, we'll get XCM is equals to M1 क्या होता है students? M1 here is 4 kg. Its x coordinate is 0. ठीक है. And X2, okay, let us write the x coordinates. 4 kg के xy coordinates are 0, 0. इसके x coordinates are, so this will be, okay, let me mark a different color. This will be x of this 2 kg mass, and this will be y of this 2 kg mass. Okay, and it will be how much? Since the angle given here is 37 degree. Okay, so this will be 5, this will be 3, this will be 4. Simple. So from this I can say 5 cos 37, if you find it will be again 4. So y iske coordinates aise honge, this will be 4xy3. 4xy3. Okay, we'll write 4xy3. Simple, students. 4xy3. This is x coordinate. Okay, so simple. Now we need to put the values here. So M1, X1, M2 is 2 kg. Its x coordinate is how much? It is 3. No, it's 4. Sorry, it's 4. Okay. And M1, M2, how much mass is? Plus 2 kg mass plus 4 kg mass. This will give you 2 plus 4. This is equals to how much? Extreme will get as 4 2 ja 8, 2 4 6. So this will be 4 by 3 is the axiom. Okay, 4 by 3 is the axiom. Now let us see the YCM value. YCM is given by M1, Y1, M2, Y2, M1 plus M2. Okay. If we see the M1 mass, it is 4 kg. If we see the M2 mass, it is 2 kg. Y2 is how much? Y2 is 3. 4 plus 2, 6. Y2 is the y coordinate of this 2 kg mass. It is 3 here, you can see. Okay. So we'll write the values at 6 upon 2, 3 just 6, 4 plus 2, 6. This is 1. So from here I can say, students, it's meter, no, so that's fine. So from here I can say this is 1 meter and this is 4 by 3 meter. So we were asked to find xm and ycm coordinates. So from here we get the answer as this. The xcm coordinate is in front of you, it is 4 by 3, and ycm coordinate in front of you, it is 1. So from here we get the value as 4 by 3 and 1. Okay, this is xcm, this is ycm. This is the answer. So the students who have given this answer, JNV Hingoli students, excellent, very good. So you are the champions of today's this question. Okay, star, you will get 5 star. Fine. Okay, so all of you must text. Okay, see, only one student, I mean, one batch of the student have participated. You can also solve these questions. No, many students are there in today's class. Why are you not solving? Okay. Okay, these questions are completed. Now let us approach towards the second question. So this is the second subjective question. So you are having one more opportunity to participate. Okay. So what it says in this question, it says two particles of mass 2 kg and 4 kg lie on the same line. Okay, Jamie Hingoli students, very good. Keep it. Okay, I mean, keep this thing with you. Like always be very attentive in the class sessions, online or offline. This will help in cracking your exams, NEET or JEE, or getting the top college in KCT exam, maybe if you want. Hai. See, two particles of mass 2 kg and 4 kg lie on the same line. So this is 2 kg mass, 2 kg mass. This is 2 kg mass. And this is 4 kg mass. 4 kg mass is here. 4 kg mass. And they say that if 4 kg mass is displaced rightwards by 5 meter, yellow color, if it is displaced rightward by say 5 meter distance, okay, then by what distance 2 kg mass should be moved for which the center of mass will remain at rest same position. So they are asking from you, if the 4 kg mass is in front of you shifted rightwards, this is right hand side, you know this thing, and this is left hand side, you know this thing. If the 4 kg mass is shifted rightwards 5 meter, then they're asking from you how much this 2 kg mass must be shifted and where. They haven't told you कि left में ही shift करना. You have to think logically where to shift this 2 kg mass and in which direction, such that where, left hand side or right hand side, such that the center of mass, suppose the center of mass ki location was something here. Okay, let us take, assume this was the center of mass, position of the center of mass. Because there is only one dimension, I will keep the masses along the x-axis. So ycm and zcm are 0. You can think like this, suppose, hai na? So where you have to shift this, in the right hand side direction or left hand side direction, and by how much magnitude amount, such that the center of mass will remain at rest. Okay? So you have to answer this. I'm giving you 1 to 2 minutes for this. Answer this, then I will give you the solution of this. Okay? Answer this here. I'm giving you 2 minutes to solve this. Okay, JNV Gondia students have also joined. That's good. Okay. Okay, students. No. Okay, I'm solving. I'm solving, students. Okay. You focus here carefully. Okay, one student have given the answer. Two kg mass is connected with 4 kg mass. Okay, if the 4 kg mass is shifted rightwards, this is a location of new location. This is the old location. This is a new location. This is the location. Okay, and this 2 kg mass is here. Suppose they are at some distance. They haven't given the distance in the question. How much this must be shifted such that the center of mass is at rest. See, suppose the center of mass location is, I assume this thing. Center of mass location is this. Okay. Suppose this is a center of mass location. See, you know this formula. All of you must know this formula, by the way. I hope all of you know this formula of m1 x1 m2 x2. Okay, let me write it again. Suppose center of mass location is somewhat here of two particles which are connected like this, and distance from the center of mass is say x1 of m1 particle and x2 of m2 particle. This is m2 mass and this is m1 mass. Okay, and you are on the center of mass here. Okay, so you will write like this: m1 x1 equals to m2 x2 mass moments. This is a tricky formula, and it's conceptual also, you know, because we say, if you have studied the theory properly, I mean, you have revised the things taught by the sir, so you will be able to understand this thing, that mass moments are equal along the center of mass. I can write like this: if you place your coordinates, if you place origin, more properly, if I say precisely origin at center of mass, if you place origin at center of mass, some of the mass moments will be equals to 0. Got it? Remember this always. So it is from this only that we have derived this, or we have manipulated this formula m1 x1 equals to m2 x2. Now the question is very, very simple, students. Now what do you have to do? Just apply this trick. Okay, I will say mass movement kitna hoga, 4 kg into distance shifted. I'll put this equals to 2 kg, and let us assume x is a distance shifted. Okay, so when I will solve this thing, I'll get 4 5 is 20 divided by 2 is 10. So from this I will get x equals to 10 meter. X equals to 10 meter, and this 10 meter students, is basically what? The magnitude of the shifting of this mass. So if you place 4 kg in that direction, logically, if you think, you'll get this thing, that you have to shift this 2 kg mass 10 meter in this direction. And you can check also, see that 2 kg mass is of less magnitude and 4 kg is double of the 2 kg, it's heavy. So heavy mass ko thoda shift karenge, and you can feel, and lighter mass ko double shifting karenge, so you can feel, imagine, you can feel this, like, intuition kind of feeling comes ki center of mass, the balancing point will be same. If suppose I'm placing a mass here and here. Got it? Okay, this was just for explanation to get a feel. So answer is, students, in front of you, x equals to 10 meter as the answer. So you will say like this: you have to shift 2 kg mass, in left hand side direction by 10 meter distance. Okay, clear? So let me see chat box. Okay, Hengoli student says 5 meter. 5 meter is not the answer. I'm sorry, but you tried. Very good. Okay, 10 meter is the answer. You can see yourself. 4 5 is 20. Divide by 2, you'll get 10 meters the answer. Okay. Now let us see the other questions. Okay, now this question in front of you. Solve this. Now, see, previous question, if you see, this is numerical number 3. Previous question, if you will see, in that question, it was given like this. Two masses are connected together. And if the one mass is shifted in particular direction, how much the other mass must be shifted such that the center of mass remains at the same position. Okay. But now the condition is different. I mean, now the things are changed. Now they are saying you like this, that the two masses are connected. Okay. What they're saying? They're saying like this, that the two masses are connected. Okay. And if the 2 kg mass is displaced rightwards, then what distance 1 kg mass must be displaced such that the center of mass will also get shifted by 2 meter rightwards. Got it? So previously we have to make the center of mass, if it was static, finally also we have to make it static only. It's not moving. Okay. But now the things have changed. You have to shift center of mass now. So how I will solve this question? I'm giving you 2 minutes for this. Okay. So I'm giving you 2 minutes for this. Solve it. And text me the answer in the chat box. Given you 2 minutes to solve this question. Please reply in the chat box. Okay. Okay, I'm solving this. Focus here. Okay. How to solve this? Focus here. So here is your solution on your screen. Two particles of mass 1 kg and 2 kg. Two particles of mass 1 kg and 2 kg lie on the same length. So this is 1 kg mass and 2 kg mass lie on the same line. Okay. If 2 kg is displaced 10 meter rightwards, so if it's displaced 10 meters rightwards, then by what distance 1 kg should be displaced so that the center of mass will be displaced 2 meter rightwards? Okay, so they're saying now 1 kg mass must be displaced in what direction such that the center of mass, suppose its center of mass is lying here, such that the center of mass will be displaced 2 meter rightwards. Okay, rightwards matlab kaun sa? I have already told you. This is right hand side direction and this is left hand side direction. Okay, how much this 2 kg mass must be displaced such that the center of mass will be displaced 2 meters rightwards. Simple. I'm solving this. Be focused. Okay, so we are having 1 kg mass. I will be fast now. Okay, I have already given you the basic steps from the beginning. I mean, we were slow. Now I'll be fast for remaining questions because you have catched that pace. Okay, I mean, you catch that you have maintained the frequency now. So you got it that we are on the center of mass and we have started it now perfectly. So these are two masses, okay, and 2 kg is displaced by 10 meter rightwards. So 2 kg has been displaced 10 meter rightwards. That's fine. Suppose the initial location of center of mass is this. Okay. Finally, they are saying that the center of mass must be shifted 2 meter rightwards. Okay. One thing to understand is this. Okay, let us take coordinate system on the center of mass like this. Okay. So I will say when the 2 kg is shifted here, so its new location will be C. Okay, let me write it R plus 10. Okay. And of this, if I'll say, suppose it was initially R dash. Okay. And let me keep it R dash. Okay. So first of all, write like this: 2 kg into R, 1 kg into R dash is the initial picture. When I'm keeping my coordinate system on the center of mass initial location. Okay. Center of mass initial location. Okay. Now, this is R and R dash. So the relation between R and R dash will be like this: R, twice of R will be equals to R dash. Fine. Okay. Now let us see. So now they're saying this. It is 2 kg mass shifted 10 meter in here. Okay. So 10 meter. And the complete distance is R dash plus R. Mass is here now 2 kg. And center of mass is not at now 0, 0, by the way. 0, 0 was here. Okay. Center of mass is shifted 2 meters rightwards. They have seen 2 meters rightwards. What does it mean? It means center of mass ka new location is here. That is, it is at 2, 0 now. Okay, so I will say axiom will be now 2 and y sim z sim is 0 because it is on the one dimensional line only. Masses are where the masses are, center of mass approximately lies there only. Other than the cases like boomerang and all that. Okay, so axiom is 2 here. Okay, and this mass they're asking from us where to shift. See, logic says like this: this mass will be shifted here in this direction, that is right hand side only. Okay, but we have to see how much it is. Simple, students. Put this axiom formula in front of you. So I'll give you this question as a homework. Okay, I'm giving you a format to how to solve. Axiom kitna hai? 2. We know the axiom formula is m1 x1 and only two masses are there, m2 x2 and m1 upon m2. ठीक, axiom is 2. m1 kitna hai? m1, let us take this 2 kg as m1. Okay, m1 is 2 kg. Total distance is how much? m1 ka distance kitna hoga? It's, see, r plus 10 meter. Okay, you can take r plus 10 meter there. ठीक है, r plus 10 meter is the and m2 is 1 kg. उसका कितना है? It is r dash plus r dash minus something, r dash minus something x. m1 plus m2 is 3. Okay, so see, r and r dash value you can use from this formula. I mean, compare this 2r equals to r dash, put in terms of r, x you'll get in terms of r, you'll write that answer. Simple. Okay, if we solve it, it's 6. 2r we are getting as r dash, and this is equals to 20, and this is r dash minus x. Okay, fine. 2r will be equals to r dash. I placed directly here. So this will give you the value as x will come out from this equals to twice of r dash plus 18. This is x value. Okay, twice of r dash plus 18. So I mean, you have to shift this particle by x here, which is equals to twice of r dash plus 18. Hold on. Okay, so what do you need to do in this? You have to do some manipulation. You have to shift this. When you're shifting the center of mass, you can shift the origin also here. Okay, and apply the formula m1 m2 m1 r1 m2 r2, and then get the answer. It's simple. Okay, either you can use this approach, x equals to r dash 18 for this, and you can find this r dash value. Wo kitna hoga, that you have to find yourself. Okay, I'm giving you this as homework. You have to find r dash your value. Use this, or you can sort of use directly m1 r1 10 into 2 and then 1 into something this, but that is for center of mass, that shifting. Or you can delete these quantities from here, then you get the answer. Okay, I'm giving you this as a homework. Okay, at last I'll give you a hint to solve this properly. Okay, now let us approach towards the second. So this is important. Numerical number 4, students, be focused here. Us question ko don't focus a lot on that. Okay, I'll give you a hint at the end. Usme kya error hai. Okay, now please focus here. See, there are two discs given to you. Now you need not have to solve. I will solve. There are two discs given to you. This is disc of radius r. Please be focused here. This question बहुत important है. They were easy questions. Okay, just the mathematical approach must be clear. This is a disc of sigma surface density, and this is a disc of 2 sigma surface density. This is mass density. Sigma मतलब mass upon area. ठीक है? और उसमें कितना है? उसमें 2 sigma is mass, total mass of the disc upon area. ठीक है? This is for this disc. This is for B disc, A and B. They say that when these two discs are placed together like this, so find out the position of the center of mass of the system. It's a rigid body problem. Okay, so this is from rigid body kind of thing. How to solve this? So I'm telling you this here. See, center of mass of A disc will be at center because it is what? Circular disc, and disc ka center of mass we have studied where? It is at the center. Okay, so I will say if it is at the center, I can say like this: mass of the disc A will be sigma of that disc A into area. Finish. This is the mass of the disc. And B disc is, this is A disc, this is B disc, and B disc is like this. Iska sigma into area is this. This is the mass of the disc B. Okay, and distances between the disc is how much? It is 2r. 2r is the distance. And now they're telling you to find the position of the center of mass of the system. Position, simple. So I have changed the question like a two-body discrete system, particle system. I have changed this rigid body numerical as two-body discrete particle system. So solve it now, simple. So take a yellow line, draw here. I mean, I'm just showing you here. Sigma into pi r square mass, and it is at distance equals to 2r. Another mass is 2 sigma into pi r square. ठीक है? Find out the position of the center of mass. कैसे होगा? See this here. Keep your origin. ठीक? Now find the coordinates. We know this thing here. The particles are along the same line, one dimension. It means only axiom will be there. Y sim, Z sim 0. ठीक है? So I will just directly find the axiom value. So axiom value will come out to be 2 sigma pi r square into 2r plus sigma pi r square into 0. Okay. Upon the total mass is how much? Total mass given is 2 sigma plus sigma pi r square. Okay. Sum these two. This will write here like this, 2 sigma pi r square into 2r. This will be 4r. Okay. So I'll get 4 r cube sigma pi into 0. This is 3 sigma pi r square. Okay. Now let us delete the remaining values. Sigma pi cancels, r square by r. So ultimately you'll get this answer. Axiom you are getting as 4 r by 3. This is the x coordinate or the coordinate of this center of mass, or location will be like this. The disk is connected with the other disk at this point. Okay. This is what? O. This is O dash. This is at r distance. This is at r distance. Okay. So I will say center of mass will be where of the disk. It will be from here. I'll keep the origin here. It will be at 4r by 3. That is somewhat here. So center of mass is lying here. From this at 4r by 3. Okay. This is the center of mass location. Clear, students? Yes or no? Yes or no? ठीक है, तो उसमें mark करेंगे तो you can say it will be somewhat here 4r by 3 from here if I place origin here. ठीक है, cleared? Yes. Okay. So now let us see this. So this is another kind of numerical. Okay. Previous was like this. If you take a rigid body disk and connect together, where is the center of mass? So now the question is like this. If you are having a rigid body, a kind of, this is what? Position of the uniform lamina. It's a uniform lamina disk. Okay. And you take out a disk from it. Okay. It's to make it hollow. Like this. So where will be the center of mass now? Okay. इसमें कैसे करना है student? It's very easy. For this, I will assume like this, that this is actually what problem? It's a cavity problem. Cavity. It's not teeth cavity. It's a cavity kind of key. You're making a hole in between. Okay. So what is this? You can change this problem into combination of rigid body and find the center of mass. Combination of bodies. That is the previous problem. You will say, how, sir? This is impossible. The mass is deleted from this. How can we combine the two bodies and make such condition? Yes, you can. Combination of bodies. So you can convert this problem into combination of bodies like this key. If I take a disk of radius equals to a, this is a radius, no, a radius disk. Okay. Mass density is constant here, sigma. Okay. If I take a disk having the mass equals to, iska mass kitna hoga? If you see, it is the mass is equals to sigma into pi a square. This is the mass of this disk. Okay. And then I combine this disk with the smaller disk of radius equals to a by 2, but the sigma density, the mass density of this, mass density of this is minus sigma. Okay, so how they are doing mathematical manipulation, I hope you get it now. So when I will place this minus matlab deletion of the masses, deletion of the mass density directs us towards the deletion of the mass. We are deleting the mass, we're removing the mass from this. So when we'll place this thing just here, again we'll get this figure. We'll get this figure. Okay, fine. So let us start it and find the location of the center of mass. So this is the picture. What I did, I took a disk, I took a small disk. This disk is having the radius A completely filled, sigma density, fully filled. Okay, nothing empty. This is minus, it's empty, it's hollow, and it will make other person also hollow. Okay, so if company it will do, if its company, it will make this also hollow. Fine. We must choose properly the companies. Okay, so it's like this is plus sigma, this is minus sigma. So this is here, if you see, this is origin, this is O dash. Fine. Now let us combine these things. It's coming inside, it will make it hollow and ultimately give you this figure. Okay. See students, if you focus here, this is origin of this complete disk. So I can compare. I can now again manipulate this numerical into two-body discrete particle system numerical like this. See, I will say like this here. That this mass is some particle having the mass equals to sigma pi a square, and this is a mass of some particle which is equals to minus sigma pi radius a square by 4. Okay, and you have to find the axiom now because masses are again placed on the one dimension only, x-axis only. Okay, so simple. This is origin, this is some coordinate, I don't know what is it. Okay, it's given. Okay, we are connecting like this. So you can, okay, from here I can say, देखो, इसका center of mass will be here. Of this disk also the center of mass will be here. So when we'll combine it, O and O dash are the consecutive, like side by side center of masses. So this is the line joining them. This is I've taken as origin. Okay, this complete distance is how much? It is equals to, see, it is equals to A by 2 only. Okay, fine. So I will say this distance in front of you is A by 2. This distance is equals to A by 2. Now apply the formula. Formula of axiom, because the masses are along the same line. This will give you, उसका तो 0 हो जाएगा, इसका कितना होगा? It will be minus sigma pi a square by 4 into A by 2. ठीक है? Or if we add the masses, this will be sigma pi a square 1 minus 1 by 4, because minus sign is there, no? So from this, if you solve this, you will get axiom is equals to minus sigma pi a cube by 8. In the denominator, you will get sigma pi a square. ठीक है? कितना है ये? 3 by 4. इसको solve करेंगे. The things which will get deleted is in front of you. Sigma pi square goya a आया, and finally you'll get the answer as minus 4 by 3, 8 here, ठीक, a. So this will be equals to minus a by 6 is axiom. Axiom will be equals to minus a by 6. This is axiom, students. Okay, by axiom is 0. So we'll say here, when you combine these two bodies in front of you, center of mass is in the negative direction. It's true here. It makes us feel, yes, you know, by seeing only we can visualize, we can imagine this thing, we can feel this thing. The center of mass will be somewhat there, not in the hollow condition. So it's, if this was the origin, minus a by 6, matlab something here. So its center of mass is lying here, a by 6 distance from here. Okay. This is the center of mass location. This is the position of CUM of this body. Is it clear, students? I hope the answer is clear to you now. I hope, students, the answer is clear to you now. Clear ho gaya na? It is clear. Okay, let us move towards the next now. So students, last question in front of you, then we'll end the class. Okay. This is the last question of today's class. Then we are going to end it. Fine. Then we are going to end this class today. Focus here carefully. It's important question. It's important question. Focus here. Okay. So it says like this. This is a person here standing. Okay. This is some, like, we are going to play outside. We are, for cricket and all these things. So I'm just going to play. I'm standing on a plank like this. Okay. And the mass of the plank is equals to 20 kg. Okay. And the surface resting on a smooth horizontal floor. I mean, it means like this, the friction is zero here. There's no friction coefficient, which directs us towards the signs that friction is zero. I mean, it's like icy condition. Okay. And man of mass 60 kg. Suppose my mass is 60 kg. And I'm standing here on one of the edge. Okay. And if I start moving like this, let me show you the video. So suppose this is a horizontal track. If you are standing on this, and if you're moving like this, see, this will also be moving towards the back direction because there is no friction. Okay. If you focus on the contact points between the feet of this person, that is me, and this plank, okay, what will happen is this, that how we walk, which Newton's law, which law of Newton helps us in walking? It's Newton's third law of motion. I mean, you can apply that law here. Actually, it's the friction which allows. Okay, so we'll say like this. See, man in the plank is having the friction. That's fine. Otherwise, it will not move. I mean, it will be very complex condition here. Slipping will occur. Okay, so we say like this: if man is moving in the forward direction, it will apply a force. See, focus here. No need of lot of explanation. Okay, fine. No need of lot of explanation. Just be focused here. What I'm saying is this. Here a person is there. He's standing. Okay, it's moving like this. So assume like this. The plank is going towards the back direction. We don't have time. Plank is moving towards the back direction. Okay, it will move. Why? Because if I am walking, I'll apply the force on the plank in the backward direction, F. So in reply, in reaction, according to the Newton's third law of motion, to every action, there is equal and opposite reaction. To every action, there is equal and opposite reaction. Plank will also apply a force on me in forward direction due to which I am moving here. Okay, fine. So if my force which is applied on the plank will give acceleration to the plank, small amount of acceleration as I'm progressing forward, and the plank will move back. Suppose the plank moves by such a condition, the plank moves x back. So when I will reach here, according to the ground frame, according to AC, with respect to the plank, I have moved 10 meters. That's fine. But the person who is standing on the ground, like we, or us, like me, okay, we'll see like this, that to him it looks like it has moved 10 meters, but actually with the ground frame, this person has just moved 10 minus x meters. 10 minus x meters. Okay, so I will say it's asking the question to find key plank, how much the distance plank has moved. So we'll apply the center of mass concept. You know this thing, that the center of mass is at rest because no external forces are acting. See, the force which I am applying, it's an action reaction. And I'm applying on the plank, plank is applying on the me. There's no external force. So whenever there are action reaction forces like internal forces ka sum is always equals to 0. And whenever external force is 0, we note this thing, according to the Newton's second law, momentum is constant. Okay, and we also can derive like this. If you have seen the theory points, and no need to recall a lot, we can say like this: mx remains constant due to this. Some of the mx remains constant. It's same like discrete particle system. Okay, So center of mass is at rest. So I will say like this. Suppose the center of mass of the plank and the man is its center of mass plank ka idhar hai, man ka mass idhar hai. So at center, the center of mass will be. So I will say like this. Center of mass is here. Center of mass is here. Okay. So when the center of mass is at rest at this condition, finally also it is at rest. Why, sir? Because there is no external force. Remember always the point. Whenever external force is equals to 0, center of mass will not be moving, irrespective of whatever internal forces are acting. Because some of the internal forces, it's like action reaction. Action reaction always cancels each other. Remember, never forget. Okay. So if external force is 0, I will write like this here. What to write? That mx is constant. This you can easily get derivation. Just revise the notes which I have provided you. Okay. So finally, we'll get mx equals to constant. Okay. So when you're standing on the mx, I mean the center of mass, if I'm keeping my origin like this, origin O, I will write like this now, that m1 x1 equals to m2 x2. Same like discrete particle system. Okay. So here m1 x1 equals to m2 x2. M1 is the mass of V, 60 kg. Suppose we have moved according to the picture which is in front of you, it's 10 minus x distance we have moved with respect to ground frame. Okay. So here, whatever values you are writing here you have to write with respect to ground frame. Ground frame. It will give you direct answers, practical ground frame answers. Okay. This is also from the ground frame. This is 10 minus x. Our mass plank is 20 kg. No need to put the signs here. It's automatically set. See, sum is 0. No, I told sum is 0. So it means m1 x1 plus m2 x2. So this must be negative. Then only it will be equal. We can compare this as equal. No. So ultimately you'll get an answer. Negative matlab that side, positive matlab positive direction. Simple. Okay. Put it directly x2. So from here 600 minus 60x plus 20. I mean into 20 x2. So from not 20 x2, this is x by the. Okay, this is x2, but x2 value is x. Okay. That's why the remaining x1 is 10 minus x. This is x2. X. Now when you will solve this thing, 600 80x. So from this you get it. Answer is 60 by. Yes, it's fine. 60 by 8. Okay, so you'll get the answer as 7.5 centimeters or meter. Okay. So the answer is this. The conclusion of this, when the boy has moved 10 meter with respect to plank. Okay, plank with respect to ground, or with respect to RI, plank with respect to ground frame have moved 7.5 meters or 14 by 2 meters. Okay, no, it's 715 by 2 meters in opposite direction. Okay, students, I hope you understood this. So that was all about today's class. The time is up. Best of luck for your future and best of luck for your other classes, and like study well. Today's Sunday, you can enjoy it sometime, and after that revise all the things of previous week, and for reference take HCV. Okay, and rest sir will guide you. So participate in the polls, feel comfortable, and then can leave the class. Okay, participate fast, students, then you can leave the class. That was all about today's class. I'm stopping the live streaming here. Bye bye everyone, take care, study well, be happy. Okay, so bye bye all the YouTube students.